Thank you for joining us to learn more about the Agent 365 SDK. I'm Aarti Saravanakumar, Principal Architect in Microsoft, and in this talk, you will meet Tahir Sausa, Principal Engineering Manager at Microsoft, who will be showing you how you can extend your existing agent to Agent 365, and also Rashmi Mansoor, Principal Product Manager in Microsoft, who will showcase testing and publishing and invoking your agent. We'll cover how Agent 365 will empower your agents to behave more like human employees, interacting with your users in the productivity surfaces and apps they are familiar with, using gestures like @mentions and emails and comments. Agents will gain these additional capabilities while ensuring that IT administrators have complete visibility and control over their activities. As developers, you have agents built on agent stacks from Microsoft Agent Framework, Copilot Studio, OpenAI Agents SDK, Cloud Code SDK, or LangChain, and hosted in cloud providers of your choice. Agent 365 SDK is not a replacement for your agent stack, but rather seamlessly integrates with your existing agent, regardless of its architecture or hosting environment. Agent 365 SDK provides samples in C#, Python, and JavaScript. And we have Get Started samples for all the popular agent stacks in our GitHub repository. For IT administrators, Agent 365 extends the enterprise governance apps like Purview and Defender, previously used for enterprise security and governance of human users, to agent security and governance. As a developer, you can easily emit telemetry in open telemetry format from your agents using the Agent 365 SDK. This minimal instrumentation of your agent results in valuable data that is seamlessly integrated into Purview and Defender. The SDK enables integration with Entra Agent Identity, though this is optional, as some agents may prefer to operate using user's identity. When an IT administrator in your tenant uses your agent, it obtains a unique Entra identity for that agent instance within that tenant. This identity serves as the central persona for the agent throughout its life cycle, handling notifications, utilizing tools, and emitting telemetry. Agents can receive tasks from users via Teams and Copilot messages, be triggered by emails from their own inboxes, or respond to comments in Word documents. To enhance productivity, users require state-of-the-art apps like Microsoft 365 Outlook, Teams, and Word. Similarly, you can empower your agent in the productivity realm by making Microsoft-provided MCP servers for M365 apps accessible to your agent through the SDK. As a developer, you have the freedom to select the MCP servers, and the administrator can grant access to these servers, ensuring a secure and deliberate end-to-end process. There are two additional companions to your Agent 365 SDK that you will encounter. The Agents Playground allows you to test your agents locally with simulated notifications and our productivity MCP servers, allowing you to gain confidence before you publish to your tenant. The Agent 365 Dev Tools is your trusty sidekick to discover productivity MCP servers, configure Entra Blueprint and other backend resources, and publish your agent to your tenant of choice. In the rest of the session, we'll begin with HANA, the trip planner agent built on Agent Framework in Python. HANA helps with business trip planning of airfare, hotels, and restaurant bookings. In the first step, you will learn how to extend a sample from Agent Toolkit with Agent 365 observability, MCP servers and tools, and empowering HANA to respond to notifications. You'll then learn to test with the Agents Playground and then publish your agent to a tenant. You'll also see HANA being used in Teams and the observability data available to your IT admins in Defender. Now, let me pass this on to Tahir, who's going to show you how to extend your agent using the Agents 365 SDK.
Thank you, Aarti. Hello, everyone. I am Tahir Souza, and I'm excited to present to you what our Agent 365 team has built. We are going to enhance our sample agent framework Python agent using the Agent 365 SDK and toolkit, and give it powerful capabilities from the Microsoft ecosystem. The Agent 365 SDK is open source and available on GitHub in 3 languages as of today: Python, Node.js, and .NET. We also provide an Agent 365 samples repo For this demo, I'll use the agent framework Python sample from that repo. Open the M365 Agents Toolkit extension in VS Code. It can install samples with one click. If you prefer, you can also clone or fork the repo manually. I've already configured the env file with secrets like Azure OpenAI key. Next, I'll add observability. Think of this as a detailed diary for your agent. It records invocations, tool executions, and LLM inferences, which is invaluable for troubleshooting and governance. We support one-line auto-instrumentation for several extensions as shown here. The observability core library helps adding observability for other LLM orchestration frameworks that are not listed as extensions. Next, we create an authenticated Azure OpenAI chat client using the environment variables we configured earlier. These are a few lines of code to create your agent with your desired system prompt and give it a base personality and behavior. This is the part you would usually have in any LLM orchestration framework quick start sample. We then add notification listeners so the agent can react to events. For example, emails to its inbox, Teams messages, or @mentions in a Word document. We also surface lifecycle notifications, like when a new agent is onboarded. Agent 365 SDK gives you the ability to connect to the Microsoft ecosystem through a vast and expanding choice of MCP servers. Adding it to your agent is as simple as this one call here. For quick local testing, before I deploy an agent, I've also added a way to test this via on behalf of authentication. Finally, the tooling manifest is a simple config file for adding MCP servers of your choice. Okay, and that's it. The source code is available in our open source repository so that you can quickly get started on extending your own agents. Now that we've got the agent code set, I will hand over to Rashmi, who will walk you through how you can test the agent locally in Agents Playground.
Thank you, Tahir. Before we jump into the demo, it helps to know how agent testing usually works. Agent developers move through a few stages as they bring an agent to life. Early on, before an agent even exists, you can try things out in the Agents Playground, running the agent with on behalf of authentication using your own account. Once you've created the agent blueprint and spun up its user identities with the Agent 365 toolkit, those identities become your dedicated test harness. And when the agent is fully deployed and published, you can interact with it the same way any user would, messages in Teams, emails, or even @mentions in Word. This next part is where all of that connects to the real world. We are going to test the agent we built using the Microsoft Agents Playground. You'll see me working with Hannah, the team buddy. She's wired into Microsoft's mail and calendar MCP servers, so every event and email you see is live. The flight, cab ride, and restaurant bookings are simulated, but the scheduling and communication are the real deal. Time to see how Hannah handles my prep for Microsoft Ignite. Hannah, I have Ignite on November 18th. Can you book me a flight for November 17th morning and also book a cab for me, please? Hannah finds a morning flight from Seattle to Orlando departing at 7:45 a.m., arriving 3:55 p.m., and confirms the seat assignment and itinerary. I tell her to book it, and she adds the event directly to my Outlook calendar. She will also go ahead and book the cab to Seattle Airport for 5 a.m. so I can reach the airport on time. So here's what's happening behind the scenes. Hannah's checking my Outlook calendar through the MCP Outlook calendar tools, confirming that November 17th is free and calculating a flight window that gets me to Orlando comfortably before the event starts. Let us look at the Outlook calendar now. And there it is. The flight is live on my calendar, created through the calendar MCP service. That's a real write operation from within the playground. Now let's have Hannah book restaurants near Ignite venue for November 18, 2025 at 7 p.m. with Aarti and Tahir, my colleagues. Now, Hannah checks the Ignite venue address, filters nearby options, and compares everyone's schedules in Outlook to find a time that works. She finds two restaurants, Maggiano's Little Italy and Yard House, and picks Maggiano's since it's top rated and right next to the convention center. Then she sends a live calendar invite to me, Aarti, and Tahir, for November 18th at 7 p.m. Eastern Time. The event pops up instantly across our calendars titled, "Howdy Teammates, let's celebrate day one with an amazing dinner. See you. Thanks, Rashmi." And that's all live, coordinated through the calendar MCP tools. Now, let's ask Hannah to send me a summary of the events. Hannah, can you email me a full trip summary? Hannah gathers everything she's handled so far, the flight, cab ride, and dinner plans, and sends a formatted itinerary to my inbox. The mail MCP handles this one. The email appears in real time, just like any message I'd send through Outlook. And there it is, the full summary ready to forward or print. All of this came together in under 5 minutes. That is the power of the Agent 365 SDK and out-of-the-box MCP servers. So that's Hannah, the team buddy, tested right here in the Microsoft 365 Teams playground. The bookings themselves were simulated, but the email and calendar updates you just saw were real, powered by Microsoft's mail and calendar MCP servers. In a single conversation, she handled travel logistics, coordinated teammates, and delivered a full itinerary, all while staying in one chat thread. That's the power of connecting intelligent orchestration with live Microsoft 365 infrastructure, grounded, reliable, and ready for scale. Now, over to Tahir, who is going to take you through how we can use Developer CLI Toolkit.
Thanks, Rashmi. After some iterations of testing, improving the system prompt, adding more capabilities, error handling, etc., we now have the agent code ready. Now, let's use the Agent 365 dev tools to set up, deploy, and publish the agent. Start with A365-H to see available commands. Use A365 config init to create a config interactively. I've already created mine, so I'll run A365 config display to review it. This config is used throughout the next steps. Use A365 develop to list available MCP servers and add the ones you want to the tooling manifest. You'll see it update in place. Next, A365 setup creates the agent blueprint, configures the necessary permissions for the MCP servers we listed, and registers the blueprint for deployment. Next, we'll use the A365 create instance command to create an instance of the agent blueprint we just created and assign necessary licenses to it. This agent instance will also be assigned a manager based on your config. Use A365 query entra to view the entra scopes created for the blueprint and instance. This is useful to validate permissions required by the agent. Now, deploy the Python agent into an Azure web app with A365 deploy. This pushes the code to a web host so it can run as an online agent. This is optional, as you're free to host your agent and provide the dev tools with the messaging endpoint. Finally, publish the package with A365 Publish to make the agent available for onboarding in the Microsoft Admin Center. In this step, you can add an icon to your agent, give it a friendly description, etc. Now that the agent has been deployed, let's check it out in Azure. There are multiple agent resources that were just provisioned. We can look through the agent blueprint that shows all the permissions required to run the configured MCP servers. So we've got our 4 servers there: Calendar, Mail, OneDrive, SharePoint, and Word. We also see the agent user that was provisioned with the required licenses. And with that, I'll hand off back to Rashmi, who will show you interactions with the deployed agent.
Thanks, Tahir. Now that we've looked at the Developer CLI Toolkit and tested Hannah's logic using Agents Playground, let's switch over to Teams to see the enhanced and published Agent 365 version in action. Here, Hannah is connected to real Microsoft MCP servers, specifically the Mail MCP and Word MCP endpoints. So when she sends an email or creates a Word file, it's happening through live Microsoft 365 services. This helps us validate how an intelligent companion behaves end-to-end across Outlook, Mail, and Word. I will start by asking Hannah to send an email. Hannah reads the instruction, drafts the message through the Mail MCP server, and confirms that the email has been sent, complete with subject, recipients, and agenda details. That covers the outbound communication part of the workflow. you can see a notification in action by Hannah saying that the email has been successfully sent. You can also see the email in my Outlook sent by Hannah with the checklist and the agenda. That is great. Next, I'll extend the scenario to document creation. Hannah generates the new document using the Word MCP server, populates it with a requested outline, and returns a live link to edit in Word online. So, within a single conversation, Hannah has coordinated both messaging and content authoring seamlessly across Microsoft's MCP server endpoints. This quick test shows how an intelligent digital teammate can orchestrate tasks end-to-end inside the M365 ecosystem without leaving Teams. From email coordination to structured document creation, and each action is executed through enterprise-grade Microsoft services with MCP servers, giving us auditability, traceability, and a complete record of every interaction. Now, let's see how we can look at the agents that are published using the Microsoft Admin Center, also known as MAC. Let's navigate to the All Agents page. Here, IT admins have a single place to view the entire agent inventory across the organization. You can quickly scan key metrics for each agent, such as security alerts, active users, total sessions, exception rates, and assisted hours. To explore further, simply click on any agent in the list. This opens the agent-specific dashboard where you'll find detailed information such as which users have access to the agent, security and compliance status, and activity metrics like total sessions, total exceptions, and total active users. This level of granularity helps IT admins monitor agent health, spot trends, and take targeted action to maximize value and reliability. Let's talk about governance of the agents extended with the Agents 365 SDK. We'll take a look at how security administrators can trace automation or agent activity directly inside Microsoft Defender. In this demo, I'll show you how to use advanced hunting under Microsoft Defender for Cloud to identify agent-driven actions and quickly create detections and alerts. We will take a look at the Investigation and Response tab, then to Hunting and select Advanced Hunting. This workspace gives you deep visibility into raw telemetry and agent events from across Microsoft 365 Defender that we just created. In the query below, run this search. This query surfaces all traces generated by agents, including invocation events, tool calls, and inference requests. It's a very fast way to audit every time an internal or external automation interacts with Microsoft 365 services. From here, I can filter by account display name to find a specific automation. For example, if I search for Hannah, I can see each tool execution logged by that automation across the environment. Opening one record shows fields such as the user ID, operation type, tool name, and timestamp, providing a full context of what was executed and when. You can also configure custom alerts directly from here. Any threats or suspicious activity detected will automatically raise an alert and create an incident for tracking. Under Investigation and Responses, Incidents and Alerts. Agent 365 Observability ensures every agent action, invocation, inference, or tool call is logged. This provides a complete audit trail for your security operations teams, allowing them to trace exactly how, when, and where each automation interacted with the system. In just a few clicks, you can hunt, investigate, and respond to automation activity all within Microsoft Defender's unified console. Okay, you've now seen the complete lifecycle of an Agent 365 experience. We started by introducing Agent 365 and its SDK, and then extended a sample Python agent framework project to turn it into a fully governed enterprise-ready Agent 365. You watched how it connected with Outlook, Mail, Calendar, and Word MCP servers, automating real workflows like Ignite conference trip planning, all while staying compliant and observable within Microsoft 365. Now, it's your turn to build. The Agent 365 SDK and Toolkit are open sourced and available today. Download the samples, explore the gallery, and start creating your own intelligent agents that work side by side with people across the Microsoft 365 ecosystem. Thank you.